Welcome back to my tutorial series on how to make a game using Flutter and Flame. In this episode, we're adding gravity, jumping, and of course, player collisions. We have a lot to do, so let's get started. To get started, I want to go ahead and clean up my code a little bit. I found some better ways to do things, and I want to change that first so we can get everything back to working how I want it, and then go from there updating it. So the first thing I want to do is go into my lib folder, make a new folder, and call this components. I'm going to take all of my components and put them in the same folder. So we're going to grab our actors player.dart file and drag that in. We're going to get a pop-up that says, are you sure you want to move this? And we do, so we hit move. And then Dart is going to want to refactor our code, which is really good. So make sure you hit OK on that so it actually updates the paths correctly. We can also grab our level.dart file and grab that and pull that into our components file, move, and OK. And then we can go ahead and delete our unused actors folder and levels folder. So now we have our main.dart file and pixel adventure, but then everything else is going to live in our components folder just so everything's together. Cool. So now that we've done that, we can go ahead and save these. And then we want to go into our player.dart file. And I found a better way to do the movement. So I want to update that now. So we can get rid of a few things. The first thing is going to be our player direction enum. We no longer need this. We can also delete it down here. We can also get rid of is facing right. We no longer need that as well. That's going to break all of this ugly if statement, so we can delete that out. We'll come back to that in a moment. And then scrolling down, it's also going to delete, mess up our entire update player movement script, so we can get rid of all of this as well. We can also comment out the velocity because we're going to get an error on it. And then right here, very important, we want to switch position to position.x plus equals velocity dot x times delta time. Our update player movement is only going to handle our x velocity, and then we'll add gravity later to handle our y velocity. So we can hit save there. And then that's going to give us an error on our pixel adventure file because we're now referencing stuff here. We can actually just comment these out. I'm not going to focus too much on the mobile side of things at the moment. We'll fix this so you can still move left and right, but we're not adding jumping in this video. The video is going to be long enough, so we're going to have to come back to this. I might not even update the joystick for this episode, but I'll show you how to in case you still want to be able to go left and right, but if you can't jump, what's the point? So we can close out of that, and now we're back into our player.dart file. So if we save and reload, everything still works, but we can't move anymore, so we need to add back the ability to move. So to do this, what we'll do is right above our double move speed, we'll make another double, and then this one is going to be called horizontal movement. And this is going to, and we're going to set it to 0. This is going to allow us to check if we're supposed to be going left or right, and then we can just change this value. So on our on key events, we can come right below where we grab our is right key pressed and left key pressed, and we can actually add in a ternary function here to see if we are actually going left or right. So first we're going to set our horizontal movement to 0 by default. This way it's always starting at 0, and then we'll check based on what we're pressing. And then we're going to say our horizontal movements, we're going to add to it a value based on if we're pressing left or pressing right. So horizontal movement plus equals, and then we're going to check is left key pressed. If left key is pressed, then we can add a question mark here, which is essentially an if statement. So if left key is pressed, then we need to give horizontal movement, we need to add a value to it. Well, if we're going left, we want to add -1 so that our player goes left. And then if we're not pressing the left key, we want to pass in 0. So in case you've never used a ternary before, it's just a fancy way to write an if statement on one line. It's checking if this is true. If it is true, we do this. If it's false, we do this. So we're going to add -1 if it's true, 0 if it's false, and then we'll do the same for the right. So plus equal, we're going to check is right key pressed. If it is pressed, then we're going to add +1, and if it's not pressed, we're going to add 0. And what this allows us to do is start at 0. If we're pressing left, we're going to add -1 to it. If we're pressing right, we're going to add +1 to it, which means if we're pressing both left and right, -1 plus 1 is 0. And if we're not pressing any other ones, it's going to be either -1 or 1 or 0. Hopefully that makes sense. Let me know in the comments if it doesn't. But now we have the ability to use the horizontal movement, and we can actually go back into our update player movement and actually use that. So we can uncomment our velocity. We want to make sure that we're affecting the velocity.x, not all of our velocity. And it's going to be equal to our horizontal movement times our move speed. So this number is going to be either -1, 0, or 1. And then we're going to multiply that by the move speed. So if it's -1, it's going to be negative move speed. If it's 0, it's going to be 0. And if it's +1, it's going to just be our move speed. That makes perfect sense, I hope. And then we're going to take that and add it to our position.x, velocity.x times delta time. And now if we save and reload, we should be able to move left and right. However, we are not animating our player, so we need to go ahead and actually add back those animations. So to do that, we can go up here to our update function. We can make a new function called update player state, and we're going to handle all of our states in this new method. So we can hit control period and create a method, and this will allow us to update all of that information. Since it's above our movement in our code, I'm just going to put it here as well. And now we can go ahead and update our player state based on certain things. So first, what we need to do is we need to grab our player state. So we can grab our player state by grabbing player state with a lowercase p. Is going to be equal to a player state, and by default we'll just do our idle player state. So nothing changes. But now what we can do is we can pass in our current. Because we're using a group animation, we have a lot of different animations, and we can pass in the current. So what we can do is we can set our current animation to be equal to our player state. So whatever our player state is, it's going to set our current animation to that. Cool. Now what we can do here is when we go left and right, our player's not facing that. So we need to change that like we had before. And the easiest way to do this is by if our velocity.x is less than 0. So this means that we're going to the left, but we also want to check to see if our scale on our x, scale.x, we want to check to see if this is greater than 0. So if we're going to the left, but our scale is normal, which means we're facing the right like we are now, then we want to just flip horizontally around the center. And now what we want to do is the opposite. So else if our velocity.y is greater than 0, which means we're going to the right, but now we've been flipped because we might have been going to the left. So if our scale.x is less than 0, which is the opposite, then again, we want to flip horizontally around center. So if we're going to the left and we're facing to the right, flip us. If we're going to the right and facing the left, flip us. And that's the only time that it's going to do that. So now if we save, we can now look left and right. Actually, did I type it wrong? Less than... Oh, I did Y, I meant X. There we go. Positive, negative, right? So now we're flipping back and forth. But now we need to be able to change our animation to be our actual running animation. So we can do check if moving, set running. And we can do if, well, we already know what running is, right? If our velocity.x is greater than 0, or, which are these two little pipes, or our velocity.x is less than 0, well, that means we're moving. And then we can just set our player state to equal our player state running. So now when we run, we're actually running again. And we're pretty much back to where we started. Everything works except for on mobile. We'll cross that in a different video, but everything works. Now, if you do want your mobile device to still work like before, at least for the running, you can uncomment the player direction and instead just do horizontal movement equals -1. And then we can uncomment this and do horizontal movement equals 1, and then uncomment this and do horizontal movement equals 0. That should get it to work just like it was before. Cool. And we'll come back to that then. So now that we're back to where we started, let's go ahead and start adding in what we're doing on this video. So we need to be going over jumping, gravity, and collisions. So the first thing we need to do is we need to actually add collisions because can't jump if we don't have collisions. We can't fall properly if we don't have collisions. So we need to do that first. So to do that, we can go to our tiled project, and then on our spawn points, we just want to move our player to the middle right here. We don't want him on the bottom block. This would make him colliding. We don't want that. So we're just going to move him up a one for when we do the horizontal collisions. So we're not colliding with anything else until we implement the vertical gravity and vertical collisions. And then we can also take a moment here to add in a little bit more of a design of how we want our game to look. So we can add a platform here. Let's add a platform here, or an object. We can also add these little platforms in here. There is a rule with platforms. You want them to be at least 2 blocks high from the prior ground. So right there, and then right there. And then let's go ahead and just add a platform here, and we'll do one here. So that's going to be our level for now. You can make this look however you want. But now what we need to do is we need to add in the actual collisions, because this is just images. So just like how we did the spawn points, we can make a new object layer, and we can call this collisions. And inside the collisions, it's very straightforward. We just need to come up here, select insert rectangle, and then start dragging out all of the collisions. Make sure you go up to view, snapping, snap to grid if it's not snapped, and then just drag out all of the collisions that we'd have for our map. So the left wall, the right wall, we'll do it this way, like so, and then we'll also do the objects. So here's our little platform. And there we go. Now for these little platforms, we want to treat them as actual platforms that our player can jump through from the bottom, but land on top. So we can still add the collisions like we need to, but we do want to treat these a little bit special. For these collisions, we need to add a class, and we'll make that class platform. You could technically make the class whatever you want, but I'm going to consider these platforms, and we're going to give it a class of platform. And now we could actually make sure that we just Control C, click Control V, and now we have all of them as a class platform. We can drag that here and here and here. And now all of our platforms are set up just the same as all of our other collisions, but we actually have to make sure that they have a class platform so that we treat them different, because they are platforms. So we can save, go back to our game, refresh, and now we have all of that. Great. So now that we have that in place, what we want to be able to do is actually add in collisions. So we need to go to our level.dart file, and we need to bring in those collisions. And I want to quickly shout out a fan that let me know that when we were doing our spawn points layer, if we don't have a layer called spawn points layer, it's actually going to crash our game. So to fix that, we need to do a null check, and we can do that by doing if spawn points layer is not equal to null, then we want to run this code right here. So we can copy this and paste it in there. We only want to do that if it's not null, and we can get rid of this exclamation point, because if it is null, if we don't have a layer called spawn points layer, it's going to crash your game. I didn't realize that because I had the layer, but good to always, check for null safety. So we'll do that. So thank you for that. I really appreciate that, because I would have never noticed that. I should have, but you'll learn. So now what we do is we need to grab in our collisions layer. So just like we did our spawn points layer, we can do final collisions layer is equal to, and then what is it? It's a level.tilemap.get layer. And then we want to make sure that we grab an object group, and then we want to call it collisions, just to match our the layer name that we gave it. So now that we have our collisions layer, we pretty much just do the same thing. We first, again, make sure that it's not null, is not equal to null. And then as long as it's not equal to null, then we can run our for loop. So we're going to do for final collision in collisions layer, and then we want the objects. We don't want the layer itself, we want the objects of the layer. So for each object in our layer, we're going to set it as a collision. And now we can do another switch statement. So we can do switch statement, and then this one we want collision.class. We want to check the class of our collision block. So for this, we have a class called platform. So we can make the first one platform. because if it is a platform, we do want to handle it differently. We need to tell it that it is a platform. And then other than that, then we're just going to use our default. So if it is a platform, well, we can create that. So final platform equals, and now what we need to do is we need to make a component that we're going to be calling a collision block so we can pass in the information that we need, our position, our size, and if it's a platform. So to do this, we can go over to our components file, go to new file, and then we'll call this collision_block.dart. And then we need to make a class for this. So the class we're going to make is going to be class collision block, and it's going to extend a position component. A position component is something where we can give it an X, a Y, and a width and a height. So now that we know we need to give our position component an X and a Y and a width and a height, which to prove that, you can actually see that all of our collisions have an X and a Y, a width and a height that we can pass through. So we can do that. Well, we can do a collision block, and we need to make sure that these are, we can actually do it like this. You just do a bracket. It's a little bit different because we're going to set our own for, is it a platform or not? So we can pass in our position, and we can pass in our size. And then we don't need this. Like our collision block doesn't care what its position, its size is. The block itself doesn't matter. However, our position component does care what our position and size is, so it can actually be drawn to the screen. So to do this, we actually do a colon and then a super. And what super is essentially doing is whatever is passed here, it's going to pass to whatever it is extending. And this took me a while to figure out. So super is essentially just calling whatever's in chart, whatever it's extending, and it's grabbing that data. So we need to pass in that data to our position component. It's looking for a position, so we can do position, and it's looking for its size, which is size. So now essentially what we're doing is we're taking our, I'll make it like this so it's easier to see. We're calling a collision block. We're going to pass in a position and a size, and then we're just going to take that and give it to our super, which is our position component, and say the position I passed in is your position, the size I've passed in is your size. But we do need one more thing because we need to see if it is a platform. So we can make our own something to pass in as well, and we're going to do a Boolean called isPlatform. And now we can just pass in this .isPlatform, which is right here. And by default, we're going to make it false. I don't want you to have to pass in if it's true or false, if it's not true. So by default, it's going to be false. If we don't pass it in, it's not a platform. But then if it is a platform, well, we're going to pass in true so that everything that's not a platform, which is all of these objects, only these 5 are platforms. Everything else is going to say I'm not a platform by default. And then if it is a platform, then we'll pass that in. Cool. So now we can save that and go back to our file. And here we just need to grab that collision block. So platform is equal to collision block. And then we need to, well, pass in the information. So the first thing is going to be the position. Well, what is the position? Well, the position is a vector 2, and it's going to be the X and Y of our collision that we've hit. So collision.x and collision.y. Perfect. And then we also need to pass in the size. Well, the size, again, it's a vector 2, and it's going to be our collision.width and our collision.height. And then because this is a platform, by default it's false. You can see that by default isPlatform is false. Well, this is a platform, so we need to set it as true. So our platform is a collision block with a position of the collision block's X and Y, a size of the collision's width and height, and then it is a platform, so we set isPlatform to true. Great. Now what we want to do is we want to add this platform to an actual list because we're going to need a reference of the list to pass to our player. So at the top, we can come up here and do list. The list is going to have a type of collision block, and it's going to be called collision blocks with an S. And by default, it's going to be an empty list. But now we can go ahead and add our platform. Now we can go ahead and grab that list, collision blocks, and add to it our platform. which is essentially just adding it to the list. We're going to search through each object. We're going to see if it's a platform. If it is a platform, we're going to create the platform or the collision block, and then we're going to add that to our list so we have all of this data to use elsewhere in our code, which in this case will be for our player. Now we also want to be able to see our collision blocks on screen. So to do this, we can do add platform. Add is a built-in feature for Flame to actually add stuff to the screen. And they're actually being added. They're invisible though, and we can't see what they are. So what we can do is we can go to collision block, and instead of having a semicolon here, we can do a brackets, and then we can just do debug mode equals true. And if debug mode is true and we refresh, now we can see all of our platform collisions. It has an X and a Y, and it also has a width and a height, which is great. And now we need to do the same for our blocks that are not platforms. So we can come under our defaults, and we can do the same thing. Final block equals collision block. And then the collision block is going to have, well, we can actually copy this because it's the exact same. It's going to have a position and a size. And because it's not a platform, by default, platform is false, we don't have to pass that in. And then we also want to add these collision blocks. We also want to add this to our collision block. So we can do collisions blocks dot add block. And then because we want to see it, we can also do add block. Great. And if we refresh, now we see all of our collisions for our blocks and all of our collisions for our platforms. But the last thing we need to do is we need to tell our player that these actually exist. We could technically just grab it from the game and all of that, but I like to just be able to pass this to our player. So to do that, we'll go to our player.dart file. We'll come up to the top, and right under our velocity, we will say list collision block, collision blocks, just like before, is equal to blank. And now we can, at the very end, after our entire for loop, now that we have all of our collision blocks calculated and created, then in our list, we can just do player.collision blocks equals the collision blocks in our level file. And now nothing really changes, but our player now knows that all of these collisions actually exist. Before they didn't. So now they have a reference of it, which is great. So we're actually done with our level.dart file. We can get rid of that. Now we can go back into our player file. And with our player file, there's a few things that we need to do because I want to be able to see the collisions of my player so that we can actually manipulate the collisions and see what we're actually doing. So to do that, we can come under our onload. We can do debug mode for our player is equal to true. And if we hit refresh, we can actually see that there is collisions around our player. That is our player's X and Y, and it's showing its width and height, which is great. Now these aren't actually colliding with anything yet. It's just images of this is where my player is. We'll actually come back to that later when we're actually going to add a rectangle hitbox. But right now we don't need to. We can just work with the collisions of our player to get you, to show you how it works. Cool. So now that we have that, what we need to do is we want to be able to check for horizontal collisions. Now, Flame does have built-in collisions, and this is what's taken this video so long because I was trying to get it to work with that. There's a great tutorial on their website that shows you how to use it with a circle hitbox, but I want to use a rectangle hitbox and it doesn't work the same, or at least I couldn't figure it out. So in today's video, we're just going to create the collisions on our own and handle them exactly how we want to rather than using built-in features. And I do apologize that this video has taken so long. I actually learned how to do this in HTML and JavaScript instead. I built this entire game from scratch again in HTML and JavaScript up to this point, and then tried to figure out how to take the collision logic from there and implement it into Flame. And yeah, I definitely like Flame, but I'm probably going to start using JavaScript in the future to make games just a little bit easier and more fun. But what we want to do here is we want to add in our check horizontal collisions. So we'll do that right under we update our player movement. After a player has moved, then we want to check our horizontal collisions. So we'll check if there is any horizontal collisions. And then we don't need a delta time, so we don't have to pass it. And then we created a new method, so we can hit control period and create a method. And that'll put it right below our update player movement. So in order to check horizontal collisions, well, first what we need to do is we need to be able to loop through our collision blocks, which you already know how to do that because we just did that. So that's very simple. We'll do for final block in collision blocks, and then we can pass in our handle collision. Now, because we're using our own collision, we actually have to code our own collision. And it can be a little complicated, but don't worry, it's not that complicated, but it is take a little bit of setup time. So to do that, we can go into our components folder, make a new file, and we'll just call this utils.dart. You can call this whatever you want. My goal would be if there's anything else I need in here, we'll just keep it in the utils folder. That way we have less and more stuff together. But you couldn't call it whatever you want, but we're just going to call it utils. And then with our utils, what we can do is we essentially just need to check if something is true or false. We need to check if our player is overlapping an object and then return yes or no, right? True or false. So we can do that by doing bool check collision. And then we need to pass in two objects. We need to pass in our player, and then we need to pass in the object that we're interacting with, which will be our block here. So what we can do here is we can do pass in a player, and then we can pass in block, just to make the naming the same. And then this is going to look like we have an error, so for right now we can just return true. So now what we need to do is we need to grab a reference to all of the information that we need from our player and our block, our X or Y, our width and our height. So to do this, we can just do final player X equals player dot position dot X. And then for our Y, let's final player Y equals player dot position dot Y. And then final player width is equal to player dot width, width, and then final player height is equal to player dot height, height. So now we have access to our player's X, Y, width, and height. And yes, we could just write it like this, but you'll see how complicated this code gets. So it's better to have the name-friendly names. And then we just need to do the same for our object. So our object is final object X equals object object.x, and then we can block. I called it block. Called it object in my other code. And then we just need block x equals block.x, block y equals block.y. There we go. And then we need final block width equals block.width, and then final block height equals block.height. Again, we're just doing this so it's easier to code. So now that we have access to our players X, Y, width, and height, and our blocks X, Y, width, and height, we need to actually return if it's colliding. And what is colliding essentially? Colliding is when you're overlapping, right? And the easiest way to check that is you need to check if our Y is inside the, if the top of our player is inside the bottom of our object, right? Let's show you. So if the top of our player is inside the bottom is greater than the bottom of our block, well, we're inside of it, right? And then the same for if our X right here, X plus our width is greater than the left of our object while they're inside, right? And that's essentially what our return is going to be. We're just going to check if all of that is true, because if we're colliding, all of that would be true. And if it is, well, we're colliding. If it's not, then we're not colliding, right? Because either all is going to be true or all is going to be false. So let's actually write that so it makes a little bit more sense. So first what we're going to do is we're going to check if our player's Y, which is the top of our player, the very top of our player, is less than our block.y, which is now the top of our block, plus our block.height. And we take the block.y plus the block.height to get the bottom of the block. So essentially this is saying is if the top of our player is less than on the y, because y starts at 0 and goes down. So if it's less than the bottom of our block, well, we're inside of it. So yes, that's a collision. Then we want to check if our player y plus our player height, which is now the bottom of our player, is greater than our block y. And as you can see, I wrote block height here, but we're going to do block height like that. Again, that's why we made the shorthand naming, so I didn't have to write it like that. So here we're saying if the top of our player plus our height, which is now the bottom of our player, is greater than the top of our block. So if our player's bottom is greater than, which means it's further down, it's inside of our block. That's a collision. Then we need to do if our players.x is less than our block. Sorry, I called everything block before. Our block x, well, plus our block height. So if our players.x is less than our block x plus its height, which is now the right of it, that's a collision. We're now inside of it. And then the last one, if our player x plus our player width, which is now the right of our player, is greater than the left of our block, which is the x, then we are colliding. And again, I messed it up here. I didn't use my proper block width. There we go. So player y is less than, here we go. I wrote block height again. I'm so sorry. Again, this is why I wanted to use shorthand codes, and then I messed that up too because in I used object before. I apologize. So player y is less than block y plus block height. So if our player's y is less than the bottom of our block, then we're colliding. If our player's y plus our height, which is now the bottom of our player, is greater than the top of our block, we're colliding. If our player's left, if the left of our player is less than the right of our block, we're colliding. And then if the right of our player is greater than the left of our block, we are colliding. Again, I hope that makes sense. It does get a little confusing also if I'm spelling stuff wrong, so I apologize. But this is what it would look like, and this is collision. So now we can go back into our check horizontal collision, and we can check to see if there is in fact a collision, because now we know how to check collision. However, I don't want to check collision horizontally on my platforms. I don't want my platforms to have horizontal collision. We're not going to interact with them if they're horizontal. It just runs the code a little bit better. It makes it seem smoother. So first we need to make sure that the block that we're colliding with is not a platform. So we could do if not block.isPlatform, which means it equals false. So if it is not a platform, then we want to check our horizontal collisions. And we do that by doing if check collision, because again, check collision is returning true or false if we're colliding or not between our player and our block. Now we already have our block because we named it block, which is great, but we need to pass in our player. In order to pass in our player, we can't just call player because that doesn't exist. We're inside of our player. But because we're inside of our player, we can just call this because we're passing in this. Whatever's calling you is the player, so we can pass in this. Now we just need to check our velocity. So we can say if we're going right, which means if velocity.x is greater than 0, that means we're going to the right. Well, what do we want to do? Well, the first thing we want to do is we want to set our velocity.x to equal to 0, so we stop going to the right. If we save and reload that, we can go, and that's not what we wanted. Yes, our player is stopping its velocity, but it's not stopping. Why is it not stopping? Because we're letting our player continue to go. What we need to do is stop our velocity, but then also change our position on the X. And well, we already know what we want it to be. If we don't want our player to go inside of it, then we want it to stop at the block.x. And if we refresh and try again, now, well, still not quite, but we are stopping. Like I can't go any further because every time we go and overlap, it's putting us back to our block's X. However, we do need to subtract the width of our player so that way we're pushed to the left, the width of our player. So now if we do block.x minus width, well, there we go. We now have collision. So let's do the same for the left. So if velocity.x is less than 0, now we're going to the left. Well, what do we want to do? Well, we want to set our velocity.x to equal to 0, so we can't move anymore. And then we want to set our position.x to be equal to what? Well, first we need to get a reference to the block's x, so we know exactly where it is in the game. And then we just need to get the width of our block so that we can get the right side of it. So if we do block.x plus block.width, we're now at the right. And you are probably going to think that we're going to have an issue with our width, and you'd be correct, right? Let's find out. So if we save this and refresh it, okay, well, yeah, we have the same scenario that we had before. Our player is getting stopped right here. So let's go ahead and add our width. So if we refresh and reload, and what's happening? Well, what's happening is something that confused me. And I'm glad that I'm able to teach you, because this took me forever to figure out. You see, if we go back up to our update player state, if we're going to the left, we're actually flipping our player. And you can see that. Right now, our X and Y is here, top left. But if we go to the left, wait a minute. Now our X and Y is at the top right. So when we move into the object, it's basing it off of our player's X, which is now on the opposite side because we flipped our player. So it's still working perfectly fine, but it's grabbing it from the wrong side. So we have to account for that. And we can do that by going to our utils.dart file, and we need to actually fix our Y based on if we're going left or right. So we can do that by doing final fixed x equals, and we need to check to see if our scale is less than 0, because that means that we're going to the left. So we can do player.scale.x is less than 0. If it is, we can do a question mark here. If it is less than 0, that means we're going to the left, and we need to pass in a different player x value. So we can do player x minus our player width, right? Because we need to get the left. Right now our x is here, so we need to subtract our width so that we're back here as if we were like when we go to the right. However, if it's not facing to the left, then our player x is fine, and we can just pass in our player x. And I spelled fixed x wrong. So now, wherever we look for our player x, we just need to use our fixed x. And if we refresh and reload, now when we go to the left, it works exactly like it should. And if we go to the right, it works exactly as it should, because we're fixing that based on if we're fixed or flipped or not. So that's perfect. So now we have horizontal collisions, which is great. But we want to be able to now add in gravity and vertical collisions and, of course, jumping. So let's go ahead and do that next. With our player.dart file, we need to be able to add in gravity. So we can go under our check horizontal collisions. We always have to check our horizontal collisions first before we apply gravity. If we check them after gravity's been applied, we're going to be in the ground, pushed back up, and we're going to still be colliding, which I'll show you when we add gravity. So you need to make sure that you do the gravity after you check the horizontal collisions, otherwise you're just going to have a lot of problems. So to do this, we can do apply gravity, and we do need delta time here, so we're going to pass in dt, and then hit control period, and then create a method. So what is gravity? Well, gravity is pretty much just a forward, a velocity going downward, right? We're adding to our player's velocity.y to make him go down. That's really all gravity is, just like in the real world. There's a force pushing us down. So if we want to apply gravity, well, we can go ahead and do that. And it's very simple. We can just do velocity.y plus equals, because gravity grows every second. Every second you fall, you start falling faster and faster. So we want to make sure that we do plus equals so that we're always taking what it was before and adding it to it. So we do need to create a variable for gravity, but there's also we also want to clamp our gravity. So we're going to add 3 variables. The first variable we're going to add is going to be our gravity. We can do that right above our horizontal movement. We'll do final double underscore gravity, because it's private, equals 9.8. You can make this whatever you want, but that's what I've chosen to do. We might change it later. You might change it based on how you want it to feel. That's completely fine. And then we also need our jump force. So we'll do final double. We're not jumping yet, but we'll do jump force. And this is going to be equal to, we'll do 460. We might change that later. And the last one we need is final double. And then this one is called terminal velocity. And terminal velocity just means that if you were falling, and we'll set it to 300, if you were falling a lot, let's say you jump out of an airplane. If you're falling out of an airplane, you're going to fall really fast. And the more you're falling, the faster you're going to fall. But eventually, the world kind of catches up with us. There's friction, there's air, and all of that. And it's going to set you to a specific speed. So eventually you're going to fall faster, 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 and then you're just going to level out and continue to fall at that exact same speed, which is still really fast. But it's not continuing and continuing. Eventually you'll level out and then just continue to fall at that speed. So what we can do here is we want to go back to our applied gravity, velocity.y, and now we can just add in our gravity. But we want to make sure that we're setting not just our velocity.y, we want to make sure that because if we save this and refresh, well, nothing happens because we're not moving our player. We need to move our player, so position.y, we need to make it our gravity. So it's going to be equal to, it's going to add equal to velocity.y, and then we're going to use delta time. So we're adding the gravity plus equal. We're going to keep adding the gravity. We're going to keep adding the velocity.y times delta time. If we save and reload, you can see our player is falling really fast. Now you can't really see that he's falling too fast because he falls off the screen, but we just want to make sure that we are clamping that so that he doesn't fall any faster than terminal velocity, especially if it was a big game. You wouldn't want him to fall, let's say, 3 times this size, he'd fall really, really fast. We don't want that. So we want him to get clamped. So we can do velocity.y.clamp. And then we need to give it a lower limit, which we already have. That's going to be negative our jump force because we want to make sure that it's negative. And our upper limit is just going to be our terminal velocity, which means he cannot go, getting an error here. Oh, I forgot, velocity.y. Velocity.y is going to get equal velocity.y.clamp. So he cannot go, our player cannot go any further velocity up, which is the negative, right, up our jump force, negative jump force, and then he can't go any further down, faster down than our terminal velocity. And you can change these. Again, we won't really see that right now, but that allows us not to be able to jump up any further and not fall down any faster than what we want in our game. Cool. So that way it's not, oh, you jumped from a really, really high height, and now he's falling much, much faster. No, we want it to work like it does in the real world. Cool. So now that we've applied gravity, well, we need to stop our player so we can start adding in vertical collisions. So we can go back up to our update. We can do underscore check vertical collisions, and then create a method. And then here, now we want to check our vertical collisions. Now for our vertical collisions, what we're going to do here is just like we did before. We're going to do for final block in collision blocks. And then we want to check, this time we want to check if it is block.isPlatform. So first we want to check, is it a platform? Because if it is a platform, we want to handle that code different. Handle platforms. We want our vertical collision to work different if it's a platform. We want to be able to jump through the bottom and land on top rather than get stopped like the rest of our blocks. We're going to come back to this so I can show you that once we add in jumping, but we need to add in the vertical collisions. So if block is platform, we'll do that code. Else, which is everything else, we're going to check the collision to see if we're colliding with a block. Again, we can pass in this for our player, and we have reference to the block. Well, just like we did the velocity.x, we can just check our velocity.y. So if we're falling, velocity.y is greater than 0. This means we're falling. What do we want to do? Well, first we want to set our velocity.y to equal to 0. If we save and reload, our player actually stops. However, he then starts sinking through the ground as if it was quicksand, and we don't want that. I mean, you might want that. That's how you actually do quicksand. Maybe you can add a little quicksand. Platform is quicksand, there you go. You have a nice little quicksand, but we don't want that. What we do want, though, is we want to set our positions.y to something, just like we did with the x, right? Well, what do we want it to set to? Well, we really just want to set it to our block.y. And if we refresh that, well, kind of. We are setting it to our block.y. We're no longer falling through the quicksand. However, we need to subtract our height from our the block.y, so that way it's the bottom of our player. So we can do that, block.y minus our width. And there we go. It immediately fixes itself. Great. Now we can go ahead here, because we're now on the ground, we're going to need this later for jumping, so we can just make it now. We want to make a variable that's called isOnGround. So we can come down here right above the collision blocks. We can do bool isOnGround equals false. And now when we're on the ground, aka we've collided with something going down and now we're at the top of it, we can set isOnGround equals true. We're going to need this later when we're jumping, so that we're only jumping when we're on the ground, so we can save some time and add it here. And then we just want to break out of this loop. I didn't break out of these earlier. It's good practice to do so, just so that it doesn't try to run anything else. I don't care about anything else at the moment. I'll check it next time, but right now we'll just break out of it. Now we can go ahead and add vertical collision here. We're not going to be able to test it at the moment until we add jumping, but we'll add it right now just because it's easy, and then we can adjust it later once we can actually see it in action. So if velocity.y is greater than 0, we're falling. If velocity.y is less than 0, we're now going up, and we just need to do the same. Velocity.y equals 0. And then we need to set the position. So position.y, well, what does that equal? Well, first we need to get our blocks y plus our blocks height. So block.y plus block.height would give us the bottom of the block. Cool. And then we can save. We'll see that in a moment when we add jumping. But yeah, now we can actually walk to the left and walk to the right. And then we can't jump yet, but yeah, our vertical and horizontal collisions are working. So let's go ahead and add in jumping. Well, jumping is pretty simple. We can come up to our variables right under isOnGround. We can do bool has jumped equals false. So this is a Boolean, has our player jumped. Well, what makes our player jump? Well, that's going to be a keyboard input, right? So we can actually come right below here and we'll do has jumped equals keys pressed dot contains logical keyboard key, and then we will be using the space bar. If you want to add other buttons, again, I don't know what arrow people use for jump. I'm going to be using a space bar, but if you want it to be any other button, you can change it here, just like we did key A and arrow left by using an or just make it whatever you want, but we'll be using space. So if our player, if our player has pressed this, has jumped will be true. So now we can actually use that to say our player has jumped, which is why I called it has jumped. So we can come down to our update player movement, and we can just check if has jumped, meaning it means it's true, has jumped equals true. Well, we can just make our player jump. So player jump, and we're going to pass in delta time, and then hit control period to create a method. I don't want it at the bottom, so we'll copy it out and put it right below here. There we go. Well, what is jumping? We need to know that gravity is grabbing your velocity.y and adding to it. Jumping is essentially the opposite, right? We're going to jump, so we're going to subtract from our velocity.y. So we can actually do that. When our player jumps, velocity.y is going to equal negative our jump force. So our jump force is a positive number, so we need to make sure it's negative. So negative jump force. And then we also need to, now that our velocity.y is whatever our jump force is, negative, right? 460, so it's negative 460, which is above us. Then we just need to set our position.y, add it to, so plus equals our velocity.y, which is what we just set, times delta time. And now that we've jumped, we can say has jumped equals false. Perfect. And if we refresh, there we go, our player can now jump. But we're running into an issue. If I hold down the spacebar, our player's jumping a ton. And we don't want that. I mean, you might want that, maybe, but I don't want that. So we need to check if he's on the ground that we set earlier. So because we know that the player jump is on the ground, what we want to do is after we set has jumped is equal to, right before has jumped is equal to false, we just want to set is ground equals false. Because if our player is jumped, he's no longer on the ground. This will let us know that we can't jump again. And then also we want to make sure that when he is jumping, we can do and. So if has jumped, which means we press jump, but we're also is on ground. So and we is on ground is true, then we can jump. And now if I hold down spacebar, we can only jump once. Then we perform our jump, we land back down to the ground. Now our vertical collision is saying, hey, we're on the ground again, and we can jump again. So there we go. We can now jump. Perfect. But we can't jump with our platforms anymore. Well, that's sad. We can jump on everything else, which is great, but not our platforms. So let's go ahead and come back and add that. So with our vertical collision, we want to just handle it a little bit different. We don't want our vertical collision to be like when we're jumping. We don't care if our player's jumping. We want our player to jump through, but we do want to stop our player if he is above the platform. So now if our code is a platform, we want to handle this different. We want to handle this different because we don't want to have, if we're jumping up, to be colliding, right? We don't want to have to worry about that collision. We only have to worry about if we're falling. So we can actually copy everything that we do for the normal falling collision. And then we just want to check if check collision. This, again, because of our player, then we just want to do that. We don't have any vertical collision if it's a platform. If it's a platformer, if it's not a platform, we do. If it is a platform, we don't want that. And then if we save and refresh, we can come over here and jump. But we're getting a weird behavior because our player is jumping, but we're going up to the next layer and we don't want that. And if we make this bigger, the reason why this is happening is because currently we're checking to see if our player's X, player's Y, the top of our player, is intersecting with the block, which it's going to because our blocks are bigger, right? So as soon as our Y hits this block, it's going to say, hey, I'm colliding, and I'm going to move it up. But we don't want that with our platforms because we don't want to check if the top of our player is above it. We want to check if the bottom of our player is above this. That way, if it's above, great, grab it and let me fall down, but not if it's the top of my player. So that's very quick and simple. We can go into utils.dart, just like how we fixed our Y, our X, we can fix our Y. So fixed Y is going to be equal to if the block is platform, So if it is a platform, we just want our Y to be different. So player Y plus player height. Otherwise, we want it to just be our player Y. So if it's a normal block, we want to check the top of our player. If it's a platform, we only want to check the bottom of our player. So we're going to take our top of our player, add our height, now we're at the bottom. And then right here where we check to see if our player's Y is less than that, we want to only add our fixed Y. We want to see if our fixed Y is less than the block width dot the height. So we want to see if if the bottom of our player is less than the bottom of our block. Otherwise, we want the top player if it's not a platform. So we can save and reload, and now we should be able to jump through them fine and actually have the behavior that we expect. Now, one other thing, my player can jump while falling. I like this approach. I don't know if you like this approach, so I'll show you how to fix it if you don't. Right under our update player movement, we can add it right here. We can do that by saying if our velocity.y is greater than our gravity, and we want to check to see if it's greater than our gravity. That means it more than one frame is passed, because every frame we're adding to our gravity. So we don't want to check it on the first one because we're always on the ground. We don't want that. And I'll actually show you that. If we were to do if greater than 0, we want to set is on ground equals false. And if we were to do that, we would run into issues. So we want to make sure that we check if it's greater than gravity. If it's greater than gravity, so that means that we've fallen for more than one frame, we're now falling. And if you want that, now your player can't jump when he's in the air. I don't want that. I like that he can fall and do that, but that's how we would do that. So we can just comment that out. This is optional. Cool. All right, and then before we move on, because we're still not done yet, we do want to add in our player state for our player jumping and falling, because him looking like this is weird. So to do this, we can come up to where we have our animations. We can actually hold Alt and bring our step time above, and then we can hit Alt, Shift, and down to duplicate these lines. This one is going to be jumping animation, and this one is going to be falling animation. And then up in our player state enum, we need jumping and falling. There we go. And then if we go ahead and scroll down, we now have our animations. So we alt shift and down. We can have jump, which is going to be 1 frame, and fall, which is going to be 1 frame, and set these to jumping animation and falling animation. And then we just need to link them to our enums. Dot jumping is jumping animation, and then falling is fall. This is what makes using these very clean. It does take a little bit to add them, but that's all you do. You add it into the enum, add a animation for it, create the animation, and then set it to our animations. Cool. And now we can save and reload, and then we can come down to where we update our player state, and now we can run these codes based on what we're doing. So we can check if falling set to falling, and then we can do if velocity dot y is greater than 0, which we'll come back to that. Player state equals player state dot falling. There we go. And if we refresh that, our player now falls. And this, again, we can do the same thing I just said. If it's greater than gravity, just to make sure that we've fallen at least more than 1 frame, we could do that. So that's fine. And then for jumping, checks if jumping set to jumping. And then we can do if velocity.y is less than 0. This one we can be 0. Then player state equals player state, equals our enum player state dot jumping. Maybe we can have these as zeros. I'm not sure. Mess around with that. I didn't see an issue when I had it as 0 gravity, but that's completely fine. We'll leave it at 0 for now, but we might mess with that later then. So my player can still jump, but now he's falling. As soon as I walk off a ledge, he's falling. Very nice and awesome. So now we have everything done in terms of our player, but the biggest issue is this is not our player size. This looks really weird if we just have this. So what we need to do is we need to create a hitbox to actually match the size of our player so that our collisions actually look proper, so that our player isn't a mile away from the block. So to do that, we can go ahead and add in a new class, and that class is going to be for making a separate hitbox. So we can do components, new file, player dot underscore hitbox dot dart, and then we can create our hitbox here. So our hitbox is going to be a class called player hitbox, and the class is going to take in 4 variables: an offset x, y, a width, and a height. So we can do final double offset x, final double offset y, final double width, final double height. And then we can hit control period and create a constructor. It'll do it for us, which is nice. Control save. But we also need to actually set these, so we can do a bracket here and a bracket here. And then we can hold down Alt and click each of them and write required. We want these to be required because A, we don't want to pass in a hitbox without this information, and B, we want it to look cleaner in our code of what we're setting, why we're setting it, rather than just setting numbers. So I like to use required so it looks easier to read. Cool. So now we'll come back to our player, and we're actually going to add that hitbox in. So we can do this by doing player hitbox is hitbox which is equal to a player hitbox. And now we need to pass in all of this information. I'll just do it like this so it's easier to see. And we need to pass in the hitbox for this. Now we can't actually see this information yet, so let's go ahead and I'm going to push in the values because I know what they are, but I'll show you how we would recognize that. So it's 10, 4, 14, 28. And then what we need to do is we can't actually see our hitbox, so we can actually add on our onload, we can add a rectangle hitbox. And this is actually what we would use to use the built-in collision detection, but we're not actually using that, but we're going to use it here to actually just see it, which is good since debug mode is on, but we're not actually using the hitbox. We're just using it as an indicator, a visual indicator, so we can see it. So position is going to, we need to pass in a position to our hitbox, and it's going to be a vector 2, and we're going to do hitbox.offset_x and hitbox.offset_y, because again we're using the offset to start at our position, and then we also need to pass in a size. Size is also going to be a vector 2. This is going to be our hitbox.width and our hitbox.height. Great. If we save this and reload, now if we zoom in, those things are essentially our x and y now starts here, which is the left of our player, and then the width goes to the right of our player, and then the height is still the bottom. We still want to make sure that the height is at the bottom of our player, but especially if your image is bigger than your player, that would help you offset those two. Cool. But again, this hitbox doesn't do anything. It's just visual. So we need to update our utils.dart file to handle our collisions so that we can actually use our new hitbox information rather than our player's box. So we can do that by going to final, by writing final hitbox equals player.hitbox. And then for our player X, we need to take our position.x, but then we also need to add in our offset, hitbox.offset.x. For our player Y, we need to do the same, hitbox.offset_y. So now our new player X and player Y is our hitbox Y, our player Y plus the offset, our player X plus the offset. And then for the player width, well, it's not actually going to be player, it's going to be hitbox. And then hitbox. So now our player width is our hitbox width, which if we go back to this, that's the width of our player here, and the height of our player. We don't care about the outside, only the inside. And then we need to make sure that we're starting from the top left of our player, getting those offsets, which is why we're adding the offsets. Great. And then the only thing we need to change, well, I'll show you in a moment. If we refresh, make the game big, it works, well, not too good. We'll fix that. But it also, as you can see, it breaks because of, well, you guessed it, our fixed X. With our fixed X, it needs to be different again, just because of how the offset is being handled. So for our fixed X, right here, player X minus, right now we're minusing player width. Now we need to factor in our offset. So we can do hitbox.offsetX times 2 minus player width. And essentially what we're saying is our player X is going to be minus our player width normally. Let's bring our player back here. Normally it's our player X when we're flipped. Normally it's our player X when we're flipped minus our player width. But our player width right now is just this big. So we have to account for this and this, which is where hitbox.offset.x times 2 comes in handy. So it's essentially, it's the same as writing player X minus offset minus width minus offset. I hope that makes sense, but that should fix our code a little bit better. As you can see, it doesn't break, it's just not pushing us the correct way. So we'll do that next so that we're actually pushed the correct way. But we're done with our utils.dart file. We can go back to our horizontal collisions and our vertical. So on our check horizontal collisions, now we need to factor in our offset. So instead of our position.x equal block.x minus width, well, we need to minus our hitbox.offsetX minus our width. And if we check that, that should make it so that we're, oh, I did it wrong. Oh, we need not our width, we need our hitbox width. There we go. Not our player width anymore. We need our hitbox width. So if we do that, now it goes flush up against it, as you can see here, because we're taking our x minus our, we're taking this spot right here, our x minus our width minus our offset, right? So that we're getting to this point right here. I know it's kind of hard to see, but that's what we're doing. And then same for the left, that's completely fine. Block.x plus block.width plus hitbox.width plus hitbox.offsetx. Great. And now that should give us the correct position there. Awesome. And then we just need to do the same for our vertical. Instead of block minus y, it's blocks. Oh, did I write width here? Well, it still works as it did in the past, but it was supposed to be height here. I apologize. It's supposed to be the height, but right now it's going to be our hitbox.height. It worked before because our width and height are the same, but this will be hitbox.offset y. So essentially we're taking the height of our hitbox, subtracting it from the y, and then also the offset y so that we have the correct location. Great. And then same as before, I messed up and put width. We need to do height. So it's hitbox.height. Let me know if you caught that before I did. And then minus offsets y, just like as before. And then the very bottom is just going to subtract the hitbox.offset y because we don't want it to be, we want to make sure that's the top of our player that we've set. There we go. And then because, I mean, we should be done. Let's just double check here. We're going to turn off the debug mode on our player. We're going to turn off the debug mode on our collisions. We're going to refresh. We're going to full screen the game. We're going to make sure everything works. And let's see. Oh my goodness, it does. Fantastic. We just made collision, gravity, and all of that stuff. And it works with our player. Look at that. Prayer looks nice up against a wall. I really hope you guys enjoyed this video. I know it was a long one. Believe me, it took 2 weeks for me to kind of figure this out. And I apologize that the video takes so long, but I actually gave up. I did give up for a few days. I wasn't working on it nonstop. I actually, like I said, switched to HTML and JavaScript, and then I'm like, well, this is so much easier. But you know, thanks to you guys leaving comments, I wanted to find a way, and I did, and it works good. I hope you guys have been enjoying these series so far. I really appreciate all the support you've given me, and I'll see you in the next video where they're probably going to add in the saw so we can die, or add in the fruit. Let me know in the comments what you'd like to see. I don't know how to do any of them yet, but we'll figure it out, and see you in the next episode.